Good evening, friends. Today we are going to discuss a very much interesting topic, that is game theory. So this is one of the topic from decision science. That is one of the decision making tool, we can say, which helps manager level people to take a decision about payoffs and about optimum strategy. So what is game basically? So in next 20 or 25 minutes, I'm going to tell you what is mean by game theory, what what are the things there which are included in game theory, what we calculate and how we calculate value of the game. So basically, what is mean by game? So game is nothing but it is it is a situation, it is a competitive situation where there are players and strategies. Okay, so in a game there are players who play that game. Actually, that person, that individuals, we can call, or a team, we can call it as a players. Whatever they play, that is a play only. And in a game, basically there are strategies. Different players, they use to have different strategies, they use different strategies in a particular game. So in that competitive situation, it is up to that player which strategy they are going to follow. So in a game, or we can say on the basis of strategies, we can segregate game into two different types, that is pure strategy game or mixed strategy game. So what is pure strategy actually? When a player always select a particular strategy in his play, then we can say that that is a pure strategy game. And when players are always select more than two strategies, but having fixed probabilities of using that particular strategies, that type of game, we can call it as a pure strategy game. There is one more thing in the game actually, that is optimum strategy. What is mean by optimum strategy then? Optimum strategy is nothing but a strategy which puts player in the most preferred situation. Then that strategy, we can call it as an optimum strategy for that particular player. In game theory problem, in a game matrix, actually, uh, payoffs are provided to you for particular players and for particular strategy. If there are 4 strategy and 4 players, then there will be a 4 by 4 matrix, and that matrix is called as payoff matrix. And on the basis of that payoff matrix, we calculate value of the game. So what is the value of the game? Value of the game is nothing but it is an expected payoff when all the players follow their own optimum strategy. It means when all the player follows their most preferred position, then that time whatever the value of the game, whatever payoffs are there, payoff is there, that is called as value of the game. Always when value of the game is equal to 0, when that answer comes 0, we can call it as a fair game. If it is non-zero, then that would be unfair game. Okay, so these are some theoretical concepts which we are going to discuss when we are going to use this theoretical concept when we solve a numerical problem and when we calculate real value of the game on the basis of 4 by 4 matrix given. So I am going to share one example with you, and I'm through this Excel sheet, we are going to solve this example. Okay, so now we have discussed what is game, what is mean by player, what is play, what is mean by strategy, optimum strategy. Then when it is called as pure strategy game and mixed strategy game. Okay. Okay, so on the basis of 4 by 4 matrix, we always can calculate value of the game. If the value of the game is equal to 0, then it is fair game. If not, then it is unfair one. So there is a payoff matrix. I have already told you payoff matrix. So here on the screen, I hope it is, yeah, it's visible. So here in the example, there are two players, player A and player B on your screen, right? So there are two players, player A and player B. There are strategies. Player A will use strategy A1 and A2. These are the two options available with A. And for player B, there are three strategies available, B1, B2, and B3. So whatever cost is there, when player A use strategy A1 and player B use strategy B1, it means A11 is a payoff when these two players use their particular strategies. So likewise, this is 2 by 3 matrix and these are the payoffs. Okay, so there is a particular method to calculate and to solve a game. So here we are going to consider one example, one matrix for this payoff matrix, and then I'm going to tell you how to calculate value of the game. Here there is a numerical for you. Just I have considered these numbers. Solve the following game to find out optimal strategy for X and Y. So this is the matrix given to you, and on this basis you need to identify optimal strategy for X and Y. This X and Y, these are two players, okay? X and Y are the players, and there are strategies. For X, there are 4 strategies as 4 rows are there, and for Y, there are 4 strategies as 4 columns are there. So there are 4 by 4 there is 4 by 4 matrix, and we are going to solve this game. So method to solve the game, first of all, we need to calculate saddle point of that particular matrix. What is meant by saddle point? That also I'm going to tell you. We calculate a row minima and a column maxima in this case. As it is matrix, you need to write down in your solution part. And now we need to calculate a row minima. These are the rows, right? And these are the column. So row minima and column minima, we are going to put here. So in this cell, from first row, this is your first row. From first row, the minimum value from first row is -5. Okay. Again, from second row, it's -5. I hope you're getting, right? Then from third row, it is -9. Minimum value. Then again, from the fourth row, it is -9. This is how we calculate row minima. Now we are going to calculate here column maximum. These are the 4 columns. So maximum figure from that particular column that we are going to write here. This is the maximum from column number 1 is 7. Then from column number 2 is 9. I hope you all are getting me. Then -5. And here it is 6. Yeah. Now, this is the way we calculate row minima and column maximum. Now here, how to calculate saddle point? Saddle point when is nothing but a cell where row minima and column maxima value are same. Okay. And that intersection point of that row and column having same minima or maxima, that is called as a saddle point. In this game, the first row value, row minima is -5, then -5, -9, and -9. Right? Here, in the column maxima, 7, 9, -5, and 6. So there is a common value, there is a common number in row minima and column maxima, and that is -5. Are you getting me? I hope it is clear. Okay. So this -5 and this -5, right? And this one. These are the same values, same figures. Okay. So your column, your row first, then second row and third column is having same value as a row minima and column maxima respectively. So whatever intersection point of this -5 column and -5 row, that is this one, is your saddle point. So -5 wala row, that is your row 1, 3, first row, third column. So that is x13, x13, and the value is -5 as it is intersection of first row and third column. First row and third column, that is -5. That is why we can say that this -5 is your x1, x13 is your saddle point sail, and your saddle point is equal to, your saddle point value is equal to, your saddle point is equal to value of the game is denoted as V is equal to -5. Here, if you got saddle point of the game, then that saddle point is called as value of the game. This is one method to get value of the game. If we are unable to calculate saddle point of a game, in that case, we need to apply different method, and that is called as principles of dominance method to solve game. Okay, so when there is no chance, or when we are unable to get that saddle point of a game, that time we need to reduce whatever matrix is given to us by applying principles of dominance, and on 2 by 2 matrix we can apply a formula, and that formula is also I'm going to show you. If here the formula is available in green color, the formula is available with you. This is A1, A2. There are two strategies for player A, and for player B is B1, B2. When we cannot find, when saddle point is not there for the game, for the matrix, then we need to apply different method. That is called as principle of dominance. We need to reduce rows and columns, and how we are going to reduce that rows and columns, that I'm going to tell you. But we need to reduce the rows and columns, and on a 2 by 2 matrix, we can apply a formula, and that formula is based on the probabilities, that is P, Q, 1 minus P and 1 minus Q we can identify, and on that basis we can find out the value of the game. Here is the formula for value of the game. We consider probability, fixed probabilities, as it is mixed strategy game. Probabilities of strategy A1, probability for using strategy A1 by player A is P. Okay, and A2 is 1 minus P. Always it is 1 minus P, because of maximum value of probability is equal to 1. It is between 0 to 1. There are two strategies. If the first one's probability is P, then second one's probability will be 1 minus P only. Likewise, it is applicable in case of player B. So, probability of using strategy B1 by player B is Q, then obviously for B2 it would be 1 minus Q. So these are the fixed probabilities, and the payoffs are given here: A11, A12, A21, A22, A22. These are the payoffs given. So on the basis of this 2 by 2 matrix, formulas are defined. P is equal to A22 minus A21 divided by A11 plus A22 minus A21 minus A12. Here there is a trick to remember this formula. Denominator for all the formula, all the three formulas, denominator is same. Only you need to remember numerator for this. Okay. On the basis of this 2 by 2 matrix, value of the game formula is equal to A11 multiplied by A22 minus A21 multiplied by A12 divided by A11 plus A22 minus A21 minus A12. This is same denominator. So this is the formula to calculate value of the game when we cannot find out saddle point for that particular game. Then we will reduce that matrix to 2 by 2 and then we'll get value of the game by using this particular formula. Now I am going to tell you how we apply the principle of dominance and how we reduce the column or the matrix provided to us to 2 by 2 matrix so that we can apply this formula. So there is a particular method to apply principle of dominance. Okay. So here I have considered one of the example. This is just a random example. You can change the values and you can apply rules of principles of dominance here and you can get your answer. In this case, if there is possibility or if you got saddle point for that particular matrix and if it is asked you to apply principle of dominance only, then you can apply principle of dominance also. Maybe you may get saddle point and again you can apply principle of dominance, but the value of the game must be equal to saddle point value. Okay, then you can say that your method is correct and your answer is correct. Value of the game is always is equal to saddle point value, whatever it is. Okay, so now there is one more example on the screen, that is player X and player Y. Okay, so player X is using 4 strategies here. 1, 2, 3, and 4th one. Again, player Y. Player Y, for player Y, there are 5 strategies. Okay, so first, second, third, fourth, and 5th one. So this is actually 4 by 5 matrix is available with you, and it is asked that find out the value of the game and optimum strategies for a particular players. And that we are going to calculate and that we are going to find out. So our first method, first we need to start with the calculation of saddle point. So we need to find out row minimas. So from row 1, the row minimum value is equal to 1. I hope you all are getting me. First, then, sorry, 1. Then in second row, the minimum value is 1 again. In the third row, the minimum value is 5. In the fourth one, it's 0. Okay. Then column maxima, we need to find out column maxima. Maximum value from the column number 1 is 6. From second is 5. Then third one, again 6 is there. Then the fourth one, 7 is there. Then from 5th one, 6 is there. Now we need to identify same if there are same numbers from row minima and column maxima. So now we can get 5. Row 3 having row minima value as 5 and column 2. So this is row 5 and this is column 2. This is what? This is same value we got here in column and a row, maxima and minima respectively. So this 5, the intersection point of same values, that 5 is your saddle point, right? So in this case, saddle point is equal to your 3, 2. So X 3, 2. third row and second column. So this is your saddle point, and the value is equal to 5 is nothing but value of the game. Okay, so we can say that on the basis of saddle point, we can say that the value of the game is equal to 5. Okay, now we can apply principle of dominance and we can get value of the game. Now I am going to tell you how to apply principle of dominance on the same matrix and how we will get the value of the game by applying method of dominance, principle of dominance. Here, if you have any doubts, if you are not getting anything, you can write in the chat box. You can ask me query regarding this. Okay, so this is the matrix given, and we are going to start with the principles of dominance. So row-wise and column-wise dominance we need to apply here. What is meaning of dominance in game theory? Actually, we need to compare here. We need to compare values of the row with values of the another row. So, for example, this is the first row, x1 and this y row. This is first row. I'm going to highlight this just for your understanding. This is row 1, right? In a matrix. This is row 2, third and fourth rows are there. Then columns, first, second, third, fourth and fifth. 5 columns are there. Now we are going to do dominance row wise first. We are going to identify which row dominate to which another row. Okay, row wise, the row which dominate to other, that row will get cancelled. But when we do column-wise when we apply column-wise principle of dominance, in that case, logic will be totally opposite. Okay, so here we are going to compare. We are going to compare first row with the second one, second with the third one, and third one with the fourth one. Here we can see that row 1 we can easily identify here. Third strategy, when X use a third strategy, that is third row dominates fourth row. All the values from fourth row is less than values from the third row. So here 2 is less than 6, this 2. 2 is less than 6, 0 is less than 5, 6 is less than 7, 3 is less than 6, 1 is less than 5. So your row number 3 is dominating to row number 4. So that we are going to cancel. Right? Now we are not going to consider this row. Right? Fourth row we are not going to consider. It is dominated and it is cancelled. Here, by applying principle of dominance, our objective is to get our 2 by 2 matrix so that we can apply our formula and we can get value of the game. Okay, now again we apply principle of dominance on a rows and then column wise we can do that. You can do vice versa also. First, if you want, you can apply dominance rule on columns first and then you can go for rows. Okay, or vice versa you can do. Now, here we can see that row number 3, that is 6, 5, 7, 6, 5. Again, this row dominate to second row, this one. Right. So, this row will get cancelled again as the third one dominates to second one. Now, here, now compare row first and row third. 6 is more than 1, 5 is more than 3, 7 is more than 2, 6 here, there is a problem. 6 is less than 7. So dominance rule, it is breaking here, we can say. It is not applicable here because of 6 is less than 7. So dominance rule is not applicable for row 1 and row 3. So here we will start comparing our columns values. Because of row wise cancellation or dominance is not possible. Now we'll go column wise. So column number 1 and column number 2 we can see. Here 1 is less than 3 but 6 is greater than 5. So there is no comparison between first and second column. Now we'll compare third and second and third. 3 is greater than 2, but 5 is less than 7. So not possible. We'll compare third with fourth. 2 is less than 7, but 7 is not less than 6. Again, we'll compare 4 with the 5. 7 is greater than 4, and here 6 is greater than 5. When we do dominance, apply dominance row-wise, we cancel the column which is dominating. Actually, the less number column we cancel out. When we apply principle of dominance, column wise, we need to cancel a column having highest numbers, having comparatively more values. That column we need to cancel. Here, column number 4 and column number 5. 7 is greater than 4 and 6 is greater than 5. So here we will cancel out column number 5. Again, we will compare column 1 with 2, but not possible. We know that. Now we can compare column 2 with column 3 or column 3 with column 4. Now, first column, we can see here. First, 1 is less than 7. When we compare column first and column 4, then 1 is less than 7 and 6 is equal to 7. Again, this column is fourth column is dominating to first column as equal value and less value. So here we will cancel column number 4. Now we can compare here first column and third column again, right? So 1 is less than 2, 1 is less than 2, and 6 is less than 7. So we need to cancel out column number 3 as it is having highest number or comparatively greater values. Now we have 2 by 2 matrix with us, but still we can apply principle of dominance. Again, we can start with rows. Okay, as per your convenience, you can start with row or column, or if you have started with rows, you can we can say next iteration we can apply on columns. If you are doing by columns and in between, if you want to cancel a row, you can do that. As per your choice, you can apply this principle of dominance on rows and on columns. So here, again, we can apply principle of dominance row-wise. So row number 1, now 2 values are left here, 1 and 3. And in the third row, 6 and 5. So here, we can easily say that column number 1 is having less values than row number 1 is having less values than row 3. Here we can cancel out row first, because of when we do dominance row-wise, we cancel comparatively less values rows. Now we have 2 columns with us. Okay, so this 6 and 5, this means 2 columns in a particular matrix. These are 2 columns. Now, if we apply the principle of dominance here, column wise, the 6 is greater than 5. So when we apply column wise, we need to cancel the value, we need to cancel the column having comparatively maximum value. So 6 will get cancelled. And now there is only one value with you, that is 5. And this 5 is the value of your game. This is how we have applied principle of dominance here, and we got value of this particular game is equal to 5. Okay, so this 5 value is with when they can have a value of the game as 5, value of the game is 5, and it is in a column, we can say that x3 2. This is a sale when X use third strategy and Y use a second strategy. Then the value of game will be is equal to 5. So optimum strategy for X is third and optimum strategy for Y is equal to 2. Second strategy is optimum strategy for Y. That means second is the most preferred strategy for player Y, and third is the most preferred strategy for player X. Okay, when we write it down in probabilities, so this is the way we write it down for X. For X is equal to, for X third strategy is optimum strategy. So we will write it as a, for first strategy 0, for second strategy 0, then for third one is 1, and for fourth one is 0. For Y, for player Y, the optimum strategy is, second one is the optimum strategy, and we will write it as 0, 1, as a second is optimum strategy, 0, 0, and 0. Okay, so this is the way we apply principle of dominance, and we can find out value of the game. When on a 2 by 2 matrix, the principle of dominance is not possible when there is no row or column which dominates each other. Then we'll get 2 by 2 matrix, and we can apply our formula which is already there on the payoff matrix, on the 2 by 2 payoff matrix, and we can get value of the game very easily. So in game theory, we generally calculate value of the game, and we find out optimum strategy for the players. So what you need to remember, there are two types of, I'm just going to summarize this. There are two types of strategies, pure strategy and optimum strategy. Always remember that there are two methods to solve a game. First is by finding out saddle point of a game. Saddle point, to find out saddle point, we calculate row minima and column maxima. If there is a similar same value in row minima and column maxima, the intersection of that particular row and column, that will be your saddle point. If you are able to find out saddle point of a particular matrix, then the saddle point is nothing but value of the game. You can apply principle of dominance on the same matrix also. Principle of dominance, for that we can apply dominance rule row wise or column wise. This is as per your choice. In row wise, you need to identify a row which dominates other row. So the row which dominates other row, the highest value row, that we do not cancel that row, but the lowest value row, that we cancel out. The same logic we apply for column, but in column dominance, we cancel out the column having maximum, or we can say highest values. So this is the way you can reduce your matrix, or you can cancel out rows and columns. You have to do this iteration you have to apply this dominance rule on a rows or columns till you get a 2 by 2 matrix. On 2 by 2 matrix, still if it is possible to cancel out rows and column, likewise we have done in this particular example, that way you can do that, or you can apply 2x2 matrix formula and you can get value of the game. I hope you have understood, and if there are any queries, you can type it in your chat box. I will try to answer that in the next video. So I hope you like it. Thank you. If you have liked this video, please do subscribe and do subscribe my channel and pass a comment. Thank you so much.